This is Unit 3, Part 2, Graphing Piecewise Functions. So in this video, we're going to look at graphing piecewise functions and then also evaluating piecewise function. So the definition of a piecewise function is a function that is defined on a sequence of intervals. So we could have two, like we see here, or if we look at the bottom here, we could even have three, and we could even have more than that. But for our examples today, we're going to have 2 or 3 intervals. Okay, so graphing a piecewise function, we are going to look at this as we go through. So instead of reading these, I'm going to come back to them when we work on our first example. So our first one, making a table, choosing x values that lie within the domain. Okay, so we have a piecewise function. So I think of piecewise like it's telling us pieces of the graph. Okay, so a piecewise function. Okay, so we're going to start by looking at this first line. F of x equals 2x if x is less than -2. So on my first table here, I'm going to look at the values where x is less than -2. Okay, so normally we have our table aligned, so we would have half the values above and half the values below. But here we just want x is less than -2. So the numbers that are less than -2, so we would get less. So then if we want to find our f of x, our y values, we take x and we plug that in to our x in our equation. So 2 times -2 is -4. -3 times 2 is -6. -4 times 2 and -5 times 2. Okay, so this is our table for 2x if x is less than -2. So now let's look at x minus 1 if x is greater than or equal to -2. So if x is greater than or equal to -2, we want numbers that are greater than or equal. So -2 we want greater, so -1, 0, 1. Okay, now to find our f of x values, we're going to use this equation. So -2 minus 1, -1 minus 1, 0 minus 1, and 1 minus 1. Okay, so we have done our first step, making a table for each equation. Okay, so now step 2, graphing these points. Okay, so I'm going to look at each line as 1. Okay, so if I graph this, and you might need to pause the video, that's okay, to graph these points. So I have 2, -4. Before we graph this, notice that this says x is less than -2. So for 2x, this equation here, that is if x is less than 2. So think back to Unit 1. When we had a less than, we put an open circle. So at the point -2, -4, we're going to put an open circle. And then since x is less than 2 for the rest of these, we can put a closed circle like normal. So -3, -6. -4, -8. And -5, -10. Okay, then looking at my other points for my x minus 1, if x is greater than or equal to 2. So if x is greater than or equal to -2, then at the point -2, -3, I can have a closed circle. Okay, so there are your points. All right, we chose the open or closed circle already. So now we need to figure out for greater than or greater than equal to, our graph extends to the right, and for less than or equal to, our graph extends to the left. So instead of having a normal line that has arrows on the left and the right, here, this is going to be what's called a ray. Okay, so it only goes forever in one direction. So for x is less than -2, we're going to the left, and then x minus 1, if x is greater than or equal to -2, our line is going to the right. Okay, so this is what your graph would look like for your piecewise function. So we are graphing the pieces of our function. Okay, making our tables here. So 4x minus 3 if x is greater than or equal to 1. Okay, so we're going to start at 1, and then it's greater than or equal to, so we're going to get larger numbers. Okay, this is for 4x minus 3. Okay, so we take that x and put it in for where x is in our equation. So 4x minus 3. 4 times 1 minus 3. So if we take 4 times 1 minus 3, 4 minus 3 is 1. Okay, 4 times 2 is 8 minus 3 equals 5. 12 minus 3 equals 9. And 4 times 4 is 16 minus 3 equals 13. Okay, so now we have our x and y values. So next we have -2x if x is less than or equal to -3. So we want to look at the x values at -3 and then less than or equal to -3. So we're going to get smaller numbers. Okay, now we need to find our corresponding y values. So y equals -2x if we have these values. Okay, so we're going to take -2 times -3, you can get 6. Negative times a negative, so -4 times -2 is positive. And then we fill in the rest of our values. Okay, so this was for -2x. Okay, so now looking at this, if x is greater than or equal to 1, so over here we're going to have a closed circle at 1 since we have that or equal to. And then same thing on our blue table here. If x is less than or equal to -3, so here we would have a closed circle as well. Okay, so now I can start graphing my points. So at 1, 1, 2, 5, 3, 9, and then the next one would go off the graph. Okay, so this is x is greater than, so our line is going, or our ray is going to point to the right. So we are going to positive infinity. Okay, and then for our other piece, we're going to start at -3, 6. Okay, this is less than or equal to, so we're going to be going to the left. And that is your graph for that piecewise function. Okay, for this one, I want you to pause the video and try to get the table by yourself and then play when you're done. Okay, so looking here, 3x minus 5 if x is greater than 0. So we're going to start at 0 and we want greater than. So 1, 2, 3. Okay, now putting our x values in, 3 times 0 is 0. 0 minus 5, -5. Then we would have 3 minus 5. 2 times 3 is 6, minus 5 is 1. 3 times 3 is 9, minus 5 is 4. Okay, and if x is greater than 0, since we don't have that or equal to, we would have an open circle when x is 0. Okay, now looking at negative x plus 1, if x is less than negative 4. So our numbers would be getting smaller. Okay, so negative 4 plus 1, negative 5 plus 1, negative 6 plus 1, and negative 7 plus 1. Okay, and if x is less than negative 4, then we would have an open circle on our graph here. All right, again, I want you to pause the video and try and graph this on your own, and then see if we graphed it the same. Okay, so when we graph these, 3x minus 5 is our purple line, and those are for the values that are greater than 0. So our x values are getting greater and greater all the way to positive infinity. And then we have negative x minus 1 is our red ray, and that is when x is less than negative 4, excuse me. So that covers all the x values when x is less than negative 4. So we have our open circles with our rays. Okay, so that is graphing piecewise functions. Now we're going to look at evaluating piecewise functions when we have our input values. So our input values are what we're putting into our function. Okay, you can also think about that as our domain, our x values. Okay, so we want to evaluate when f is negative 4. So this is going back to function notation, which we briefly covered in the last unit. So when x is negative 4, we're going to have to find which part of our piecewise function we're going to use. So negative 4, is that less than or equal to negative 2, or is it greater than 2? Well, hopefully we know that negative 4 is less than or equal to 2, so we're going to use this top here, this top part. So we would have negative 2, put in negative 4 for x, minus 1. Okay, and then negative 4 times negative 2 times negative 4, is positive 8, minus 1 is 7. So when x is negative 4, our function is going to be 7. Okay, if we look at f of 3, well, we know 3 is greater than 2, so now we're going to use this bottom one. So negative 3, since x is 3, plus 4 equals 1. Okay, now we want to find f of 2. Okay, is 2 less than or equal to 2, or is 2 greater than 2? Well, 2 is not greater than 2, but it is equal to 2. So we're going to use this top one again. So negative 2 times 2 minus 1. Okay, that is equal to negative 2 times 2 is 4, minus 1 is negative 3. Okay, we have another example here, and we have 3 parts. So f of x, we want to find when let me try that again. We want to find f of -6. So we have to find which one of these -6 will fit into, which one it's true for. So is -6 less than or equal to -2? Yes, -6 is less than or equal to -2. Okay? Just to make sure, let's look at these next ones. -6 is not greater than or less than 2, is not greater than -2 and less than 2, and -6 is not greater than or equal to 2. So we know we made the right choice here. Okay, so -4 if x is less than -2. Okay, what this is saying is f of x equals -4 if x is less than -2. We said -6 is less than -2, so this just equals -4. Okay, looking at f of 0. Is 0 less than or equal to -2? No. Is 0 greater than -2? And at the same time, is it less than +2? Yes, it is. Okay, so 0 is in between -2 and 2. All right, so this says x minus 2. So we said x is 0 here, minus 2 is -2. Okay, I want you to pause and try and get this last one by yourself. Okay, so f of 4. Okay, so let's find which part of our piecewise function we're going to use. Is 4 less than -2? No. Is 4 between -2 and 2? No. Is 4 greater than 2? Yes. So we're going to use this. Okay, so -2, we put 4 in for x, add 4. Okay, now we're just solving. -2 times 4 is 8, and then plus 4. Sorry, -2 times 4 is -8 plus 4. Okay, -8 plus 4 gives us -4. Okay, so that is evaluating your piecewise functions.